Well, hello everybody. We have a treat in store for us today. We have Professor Mueller from the Department of Natural Sciences, and specifically he's a chemistry professor here at Bluegrass Community and Technical College. So I want to welcome him and thank you in advance for any tips that you will share with our GE 101 class on how to study specifically chemistry, but natural sciences. Thank you.
Sure. All right. Anyone here think they might take a chemistry class? Maybe be a doctor, a pharmacist? I got a few people. So it's very possible you may see me at some point in the future. I have a few suggestions, and a lot of times folks in sciences struggle with how to study and how to organize themselves. And I have a few tips that may be helpful, and I think that these pretty much apply to any type of class, certainly any type of science class. And the first being, start early. Please, if you take a chemistry class with me, if you could start a little early on your studying, it makes a huge difference. If you wait till the end, maybe you'll have enough time. But if you don't, you're in a bad situation. Whereas if you start early, you make sure to set yourself up to perform well. I have another suggestion. Make a plan. Oftentimes when you go to take a test, it's over 1 or 2 or 3 or 4 chapters. It's over a whole bunch of stuff. And when you sit down and you go, oh wow, that's 60 pages and 20 problems, there's no way I can do that. Well, let's say that those 60 pages and 20 problems are given to you, and you have 2 weeks to do it. And you work a lot on the weekends maybe, so since you're working full-time on the weekends, you're working double shifts, waiting on tables. That's what I was doing when I was in college. Maybe you can't work on Saturday and Sunday, but you can work Monday through Friday. So 2 weeks, Monday through Friday is 5 days, and then another Monday through Friday is 5 days. So you've essentially got 10 days where you're not hustling around trying to make money, so now you can study for those 10 days. So if you break that up, 60 pages in 10 days, how many pages is that a day? Yeah, 6 divided by 10. Six pages a day. And if you have 20 problems in 10 days, how many problems is that a day? Yeah, that's 2 problems a day. Now that's a much more reasonable thing. If you sit down and try to knock out all 60 pages and all 20 problems at once, probably not going to happen. And you're going to think to yourself, man, I can't do science. Well, that's because you set yourself up to fail. You waited till the end and you tried to do it all at once. You can't do all that stuff all at once. Set yourself up to succeed and break it up a little bit. 6 pages a day, I can read 6 pages. Figure out when you're going to do that. I have a free period in between my 2 classes. I can read 6 pages in that. And I can work 2 problems. In almost all science textbooks, they break the chapters down into sections. So chapter 9, section 1, chapter 9, section 2, chapter 9, section 3. And at the end of every section, they almost always have an example problem that you can try to make sure that you knew how to do it. So if you work the example at the end, that's a good test to see, did I understand this section? Can I do the problems that are going to come from there? Now, usually the examples, they give you the solution right there. If you look at the solution and go, yeah, I think I know how to do that, you don't really know. You have to try to do it cold turkey. You have to cover up that answer and make sure you can do it without looking at the solution. So without solution. If you have to look at the answer in order to get the correct answer, that's okay. That's a good learning tool, but that means you need to practice more. If you just practice one time, that's probably not going to be enough to do well on the test. If you want to be a rock star, you don't just pick up the guitar once and be like, hey, I did a chord, I'm ready to be a rock star. You got to practice over and over and over again. So So if you don't get that problem correct the first time, that means you need to practice that one more. That one is one that you know is going to give you trouble. So usually there's at the end of the chapter, there's a whole list of problems. Find more like that one so you can work them a little more. Another thing to do is at the end of every chapter, they usually have a chapter summary where they kind of give you the gist of each section or maybe the whole chapter. And there's two ways to use that chapter summary. One way is after you read the whole thing, look at the summary to get the big picture. But if you're reading for the first time and you're reading it and your eyes start to cross and you're like, man, I don't even know where this is going, because the language can be complicated in science textbooks, sometimes students find that it's helpful to read the summary first. By reading the chapter summary first, it tells you this is what this chapter is all about in a little short format, so you can keep an eye on the big picture as you read the individual sections. Sometimes if you know where they're going with something ahead of time, you can see it's easier to get through all the details. So sometimes that's helpful. And then my biggest mantra, practice more. And if you've done a few practice problems, you know the best thing to do next? Is do some more practice problems. There's nothing like practice to make sure you can do it more. Because when you go to take the test, if at home you did one problem that took you a while and maybe you fuddled through it a little bit, but by looking at the answer you were able to get the right one, when you go to do it cold turkey on the exam, you're not going to be able to look back at the section. You're not going to be able to take all that time. Most exams, you have a time limit there. You can't just wander around and go find the wrong answer and then eventually get it. You've got to work efficiently. And the best way to work efficiently is to practice a whole bunch. So those are my main comments. I have two more things that I wanted to bring up. One thing that I tell to my students. The first is, as you're reading and working problems, keep an actual piece of paper that has on the top questions. As you're reading, if you don't understand a particular graph in the reading, write down page 23, graph number 2. If you didn't get how to do problem 77, write down problem 77. If a whole section just stymied you, I have no idea what that meant. Write that down, because usually most professors at the beginning of every class say, does anybody have any questions? And you'll be sitting there, you'll pull out your question sheet and say, boy, howdy, I do have a whole bunch of questions. Let's go. And maybe that'll help the other people in the class as well. But if you don't write down your questions, when your professor asks, hey, anybody have any questions from the reading? You'll be like, yeah, there was that thing with the stuff. You remember the one with the... No, I have no idea what you're talking about. So by writing down a list of questions you can ask in class. Another thing that you can do is you can swing by office hours. You know, your professors have at least 5 or so office hours that they're definitely going to be there, sitting there, waiting for you. Oh, I wish somebody would come and say hello and try to learn. But a lot of students don't use office hours. So if you come to office hours, you'd be like, all right, I got my list of questions right here. Let's go over these things. Problem 77, page 22. Explain that to me. I wasn't able to get that. Or if the office hours don't work, you can often make an appointment with your professor outside of office hours. A lot of times there's tutoring available, so you sit down with a tutor. If your professor's a jerk, then go find a tutor instead and say, hey, help me out. These are the things that I have problems with. And that way, you know, you're not going to be able to find your professor all the time. And you're not going to be able to find a tutor all the time. So if you want to maximize your time with those people, have your list of questions ready so that you get all of your questions answered and you don't waste time going, I think I had a problem with, there was something, that's a waste of your time. You want to use your time efficiently, and having that list of questions can really help. The last thing I wanted to bring up, in science, the language is often very complicated. Scientists love to use their complicated terms. And I want to write down 2 terms polyatomic, big long word, a bunch of syllables, but oftentimes scientists use their words in a way that if you think about it, you might be able to break it down and figure out what it means. Does anybody know what poly means as opposed to mono?
Many.
Yeah, poly means many. A polygon is a many-sided figure. So if you happen to know that poly means many, polyatomic means many atoms. So in chemistry, we talk about monatomic, mono means one atom, or we talk about polyatomic, many atoms. And if you think about the word, and if you can break down the pieces of the word, you can usually figure out what that word means. The word hydrophobic comes up often in both biology and chemistry. Does anyone know what phobic means? Yeah, it's a fear of. If you've got a phobia for spiders, you're afraid of spiders. So this means a fear of something. Guess if something is hydrophobic, what's it afraid of? Yeah, you think about, oh, I'm hydrated or dehydrated. I have water or I don't have enough water. This is something that doesn't like water. For example, oil is hydrophobic. Oil doesn't mix with water, and so that's where that word comes from. So a lot of times, you can figure out what these big complicated words are if you spend a little time thinking about it. And the best way to get better at that, when you first start, you're going to not be good at it. Just like anything, you're not good at it at first. You have to practice it a lot. The more you read these complicated words, the more you automatically break them down and think about it. The more you start early and make a plan, the more that's just a really regular thing to do. The more you work problems, the better you become at all problems, whether it's chemistry or physics or math or whatever. The more you do it, the better, the more naturally it comes. And most importantly, a lot of people say, I don't read the textbook, it's just hard for me. I like it when the professor just explains it to me. Well, there's not going to be someone that's going to follow you around for the rest of your life and explain everything to you. You're going to have to read to figure stuff out in the future, whether it's as you get further in college or when you get a job. There's not going to be someone to walk around with you and explain everything to you. So you have to be able to read to understand. And the only way to get better at reading complicated stuff is by doing it over and over and over again. Reading is a skill, and you'd like to think, most people think, oh, I can read, that's not a problem. But can you read really complicated science textbooks? When you go out into the work field, can you read those complicated work manuals and those various instruction manuals? It's really hard to understand that stuff and to read complicated stuff unless you practice reading hard stuff all the time. So that's about my little gist of it from the chemistry and natural sciences perspective. Questions? All right. Well, thanks so much, and good luck in your college careers. If you end up thinking about science, come on by. My name's Chad Mueller. I'm in OB 234. And hopefully I might see some of you in my chemistry classes. But otherwise, might just see you around campus. Feel free to say hello.